Hey guys, what's up? This is Mr. Myasis here, and I am looking. I just want to show you. I know you might not be a race fan, but I'm so happy. Anyway, this is 6-2 for BC Calculus Inverse Trig Functions. And this first video actually is just going to be a quick review of some inverse trig functions and some of the things you got to be able to do with those trig functions. Okay, so one of the main things that you need to remember for inverse trig functions is that they have range restrictions, and it's because we can't have a I have another video on inverse trig functions for pre-calculus. If you want to go back, it goes into a lot more in depth on why we have these range values and why, some of the things we can do with the inverse trig functions. But for now, if I rush through this, you might want to go back and take a look at those. But really, the key here is that they have these range restrictions, and the importance of them is that when we're finding values for inverse trig functions, we want to make sure that those values that we get when we do an inverse trig function stay within those range restrictions, because otherwise the function wouldn't even be a function if we graphed it, and we want them to be inverse trig functions, right? So let me go ahead and whoa, what's going on there? Let me go ahead and show you some of these things here. I got on my screen here the range restrictions for arcsine, arccosine, and arctangent. Sometimes you'll see these written as sine with a little -1 there. So sine inverse, cosine inverse, and inverse tangent, like that. You're not going to need to really worry about, by the way, I know that those of you that watch my videos a lot, you know that there's a lot of flies where I'm at. It's not me. I swear the flies aren't attracted to me. Just something about this area, and I've got a lot of flies in my classroom right now. So if you see me going like this or swatting, doing some crazy stuff, it's because I'm trying to get rid of these flies. Anyway, you don't have to worry about inverse secant, inverse cosecant, and inverse cotangent. I don't think those are going to be on the AP exam. So I'll focus my attention on arcsine, arccosine, and arctangent. Okay, so let's zoom in here, and I'll show you what the graphs of these look like. So arcsine goes from -1, -pi/2, and it curves through 0, 0, and up to +1 pi/2. I'll draw that a little bit better here. All right, so that's arccosine. That's arcsine. Arccosine, however, starts at 1, 0, and goes to negative. Well, actually, I guess it starts at -1 pi, goes through pi/2, and like that. And arctangent has a horizontal asymptote. Now, if you turn these guys to their side, they're going to kind of look like what tangent, cosine, and sine look like. All right, tangent has a horizontal asymptote, goes like this, and goes through like that. Okay, so it has two horizontal asymptotes, one at pi/2 and one at -pi/2, which corresponds to the range values that we had in our table here. All right, let's take a look at some of the things here. You got to make sure that you stay within these range values. I can't stress that enough. And here's a picture here of the range values on a unit circle. So what I'm going to do for these next problems, I almost had that fly, is I'm going to use a unit circle. So I'm going to assume at this point that you have a strong grasp of the unit circle. Okay, and if you don't, then do, because you need to have that unit circle down pat. Okay, so let's go ahead and determine the arctan of 1. Basically what I'm saying is, for what angle is my tangent going to be equal to 1? And that's going to be when the sine and the cosine are equal, and the sine and the cosine are equal at pi/4. Notice I didn't say at 5 pi/4, 3, at 5 pi/4, right? I didn't say this is at 5 pi/4 because it can't be. For an arctangent, it can only be between negative pi over 2 and positive pi over 2. 5 pi over 4 is down here. Even though those are the same, sine and cosine are the same, negative root 2 over 2 and positive root 2 over 2, we can't use that because it's not within our restriction for arctan. All right, what about inverse cosine of negative 1? Again, where is the cosine? What angle is the cosine going to give me negative 1? Within my, within 0 to pi, and that's going to be at pi. Where is the y-coordinate, negative root 3 over 2 in the unit circle? That's going to be at negative pi over 3. Now, you might be thinking to yourself, well, Mr. Mises, I have a unit circle right here, and I'm noticing that that is really, that's right here. And that's, last time I checked, that is, let's see, 3, 4, 5 pi over 3. Well, 5 pi over 3 is the angle that goes all the way this way. I can't use that angle, so I have to go backwards and use the negative angle, which is negative pi over 3. Okay? So remember that when you're using arctangent and arcsine, you got to include those negative angles in there if it's in your fourth quadrant. All right, what about the arcsine of 2? Well, that says that's really asking what is the angle where the sine is going to be 2? Well, it's a unit circle, right? Not a double unit circle. So this doesn't even exist. DNE. All right, we can't even find that. So it's not even part of our problem here. All right, last example here. So let's solve for x. We have arcsine of x squared minus 3 equals pi over 2. So for this one, what we're going to do is we are going to do a little something that we do with logarithms. And we're going to take or do we do this with logarithms? I guess we do it with a lot of type of things. Like when we have a square root, what are we going to do when we're trying to solve for a square root? We're going to square both sides. So I'm just going to do the inverse relationship of a sine, and I'm going to sine both sides. Okay? Sine both sides. So that's like, I saw the sign on both sides of this thing. All right? Sine pi over 2. So we're like signing both sides. It's kind of weird, sine both sides. Sine and arcsine, they cancel each other out. And I get sine of pi over 2, which is 1. And x squared equals 4, so x is equal to plus or minus 2. All right? So if we're trying to solve for an inverse trig function, we can just do the inverse of that, which is sine on both sides, and then solve it that way. All right? So those are some review problems, similar things that you're going to need to be able to do very quickly on the AP exam in order to do some of the calculus that's involved. All right? All right, we'll catch you guys later. Bye.